Hello and welcome to Close Chemistry Lessons. Today we're going to be looking at organic chemistry, and in particular we're going to be looking at nomenclature. So at the end of this lesson we should be able to do the following, which is based from the AQA A-level specification. So you should be able to draw structural, displayed and skeletal formulas for given organic compounds, apply IUPAC rules for nomenclature to name organic compounds limited to chains and rings up to 6 carbons each, and apply IUPAC rules for nomenclature to draw the structure of an organic compound from the IUPAC name limited to chains and rings with up to 6 carbon atoms each. And all nomenclature means is to name an organic substance. So let's go and have a look. The first thing is to see what we mean by nomenclature and what the IUPAC rules are. So the IUPAC rules is a systematic way of naming carbon compounds, and it works from, first of all, identifying the stem of the compound, and we work the stem out by showing the number of carbon atoms in the longest chain bearing the functional group, and if necessary, a prefix showing the position and identity of any substituents. An example here, we've got the alkanes, and if they've got 1 carbon, then we have the prefix meth with the suffix ane. Apart from the first 4, which retain trivial names, the number of carbon atoms is indicated by a prefix derived from the Greek numbering system. So the list of alkanes demonstrate the use of prefixes: meth, eth, prop, bute, pent, hex, hept, oct, non, dec, for the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And the ending is the name, as they are all alkanes. So the ending ane identifies the functional group as an alkane. Here we go. The suffix tells us which functional group, and we're going to have a look at a whole host of suffix and functional groups that we may come across in the AS course and apply those to understanding what the chain might look like and what our functional groups and what our displayed formulas and what our skeletal formulas might look like. In many cases, the chain of carbon atoms is branched, i.e. it's not just one single chain, and in that case we need substituents, and we would need to name the side group accordingly. And we'll see how that works in due course. Importantly, when we do so, we have to give those substituents a number position, and we're going to see how we number those as well. Our general rules then that we're going to be following as we look at all of our following examples are, as for the stem, we're going to look for the longest chain of carbon atoms containing the functional group. The carbon atoms must be in a continuous row, although they don't have to be drawn in one continuous line, as we'll see. Use prefixes, as we'll see on the coming page, and the ending tells you what type of carbon structure you have. Alkanes end in ane, we'll see alkenes with an ene, alcohols with ol, and so on. Side chains, well, the carbon-based substituents are named before the chain name, that is, they come in front of the name. If it's an alkane group with CH3s, then they have the prefix "-ile" added to the basic stem. So we have methyl, ethyl, propyl, butyl. But these could also be side groups of bromo, haloalkanes, as we'll see. Number the principal chain from one end so that the side chain is attached to a carbon atom with the lowest possible number. Now the best thing to do here is just to take stock of those rules and then see how we apply them as we go on. We're now going to work through a series of known examples. Now for each of the worked examples that we're going to be looking at, we're going to be using these 3 pieces of information. The first, over on the left hand side, reminds us simply of the number of carbon atoms and the prefix that's associated with those. Now remember, for the AQA course, they only require us to know up to the first 6, but up to 10 is also shown for completeness here. If we have a side chain of a carbon chain group, then we have the ending "-ile" with the prefix, and they're shown in the second table. And the final table over on the right hand side here describes all of the possible additional functional groups, homologous series, over and above the alkanes. And you can see for our AS course we have the alkenes, described by the carbon-carbon double bond. We have the alcohols, described by the OH group. We have the haloalkanes, which is identified by a halogen, so either a chlorine, a bromine or an iodine. We have the aldehydes, which are identified by a carbon double bonded to an oxygen with a hydrogen attached. We have the ketones, which is a carbon double bonded to an oxygen, and either side of that carbon there is another carbon group. We have the carboxylic acids, which is identified by a carbon double bonded to an oxygen with an alcohol group. We have the amines, which is a carbon bonded to a nitrogen, which is bonded to hydrogens. And the final group is the nitriles, in which we have the carbon triple bonded to a nitrogen. For each of these cases, we have the suffix when it's the primary functional group, and that will give us the ending to the name, so the suffix being the ending. For the alkenes it's -ene, for the alcohols it's -ol, the aldehydes -al, -one, oic acid, amine, and nitrile. In some instances where it's not the primary functional group and there's more than one type of functional group available, it may be that we need to use it as a prefix to name it. So we have hydroxy. For the haloalkanes we have chloro, bromo and iodo. We have for the ketones oxo, and for the amines we also have amino. And that's simply if there's more than one functional group, then we can name it at the beginning of the name. We're going to use each of these for all of our worked examples that we're now going to look at. So the first one we're going to look at is from the alkane group. The alkanes have the general formula of CnH2n plus 2. And we're going to look at propane. So propane tells us that we have 3 carbons, and the ane identifies it as an alkane group. In terms of if we're going to draw this as a displayed structure, that would mean drawing all the bonds. So our displayed formula, where we have all the bonds, each hydrogen is attached to the carbon, and each carbon you'll notice has 4 bonds to it. Here we have the displayed formula. The other that we need to know about is the skeletal formula. And the skeletal formula has the hydrogens removed, and we no longer write carbon. Instead, each point is describing a carbon. So here we've got the skeletal formula for propane. We've got carbon 1, carbon 2 and carbon 3. We don't need to draw the hydrogens because that's understood that anything that's not drawn would be a hydrogen. So there is our skeletal form of propane. So next we'll have a quick look at pentane. Pent this time is 5 carbons. It's got the ending ane, so we know the displayed formula we see 5 hydrogen, 1, 2, 3, 4, 5 carbons, and the hydrogens. Our skeletal formula this time will be, and we have to remember that the first point of our pen is the first carbon, so we've got 1, 2, 3, 4, 5. There is my skeletal drawing of pentane. We're now going to move on to some slightly more complicated looking examples. This time then we're going to look at this molecule here. And the first thing to do is to count the longest chain. So we're going to try and name this, and then we're going to draw the skeletal formula. We have 1, 2, 3, 4, 5 carbons in the longest chain. So this, we're going to name it, is going to be based on pent. There's only single bonds, which means it's going to be pentane. And if I just highlight what we have dealt with so far, we've named the longest carbon chain and dealt with the fact that their functional group is a name, and we now got to deal with these side groups. So what do? Well, we look at those side groups. The first thing to say about them is they are all the same. They're all 1 carbon chain length, and therefore we can name them as methyl. We have to name how many there are, and there's 3 of them, and to do that we name it as tri. So if there's 1, there's no name, no number. If there's 2, it would be di, 3 tri, 4 tetra, 5 penta, and 6 hexa. So we've got 3, so it's trimethyl pentane, and then we have to give the numbers. There's 2 possibilities. We could start at this end. We would have 1, 2, 3, 4, 4. So it could be 2, 4, 4 trimethyl pentane, or we could name it as 2, 2, 4 trimethyl pentane. Well, if we check our rules, we need to go for the lowest number. So this we give 2, 2, 4 trimethyl pentane. This time then we'll look at our first functional group, and just once I've got the screen resized properly so you can see, there we go. We now have a carbon chain. Let's look at that first to see how we would name this one. 1, 2, 3, 4, 5 carbon in the chain. So we're based on pent again. Only single bonds, so we're ane. And this deals with our carbon chain that we have here. However, now we have some different side groups. We now have these halogen groups. So how we name them? Well, we have chloro, bromo, iodo, and importantly their prefixes. So we need to name them, and we tend to do this alphabetically. So we have bromo, chloro, pentane, and we also have to give the position. So bromo, chloro, well in fact we've got 2 chloro, so we need dichloro. We need the positions, well it could be 2, 2, 4, or it could be 2, 4, 4. The smallest number, yep, gives us 2, 2. With 4 bromo, 2, 2 dichloropentane. Naming them alphabetically, and all of the numbers given. Numbers separated by commas, and letters and numbers separated by a dash. So what we haven't done there is described it as a skeletal formula, So now we just go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. On the second carbon, sorry, actually, the fourth carbon we have bromo, and on the we have the 2 chlorines on the second. So there's our skeletal formula. We don't draw the hydrogens. This time we're going to look at a different functional group. We looked at the haloalkanes before. Now we're going to see that we've got a carbon-carbon double bond in this one, which means we're now looking at the alkenes. So naming wise, we have 1, 2, 3, 4, 5. Again, based on pent. This time we have a carbon double bond, so we're no longer ane, but we now got the suffix -ene. You'll notice I've left a space because I do need to give that a position. And if we're going to count that as the functional group, we could name from 1, 2, 3, 4, 5, or 1, 2. We actually name from this as number 1. We're going to be pent 2E, which deals with this. We've then got our side group we've not dealt with yet, which is again a 1 carbon methyl group. We need a methyl, and we need to give the position, and that's on 1, 2, 3, 4. 4 methyl and 2E. To draw this as a skeletal formula, well, let's draw our pentene. 1, 2, 3, 4, 5. On the second carbon, well, let's do it from this end so it looks like the structural formula, the displayed formula. We're going double bond there, and we have a methyl group there. So here is a displayed formula. Here is my skeletal formula for 4-methyl pentene. This time we have a skeletal formula. And let's first of all draw our displayed formula, so that's with all the bonds. And then we're going to name this afterwards. So the first carbon, number 1 there. We then have OH. Another carbon, I'll draw that one. Doesn't matter whether it's up or down there. So this, my displayed formula, I should really draw in the bonds between the oxygen and the hydrogen as well to make it a true displayed formula. Otherwise I wouldn't get the marks in the exam, so make sure you do that. Here's my displayed formula. Let's look at naming it again. 1, 2, 3, 4, 5. We've got 5 carbons, so we are pent again. We have dealt, therefore, with the number of carbons. We're all single bonds, so we're an, but we're not pentane this time, because we have our side groups here, which are alcohols. We've got 2 of them, so remember, we've got 1 we don't need to name, but if we've got 2, it's di, 3, it's tri, 4, it's tetra, 5, pent, hexa. So this is pentan, and we're going to have diol, because we've got 2 of them. The functional groups are alcohols, so it's the suffix ol, and we've got to give those position numbers. Well, it could either be 1, 2, it could be 3, 4, or 2, 3, so this time pentan, 2, 3, diol. This time we're going to look at the fact that we've now got 2 functional groups, and we've got 1, 2, 3, 4 carbons in our chain again, so we're now bute. We're not a single covalent bond, so we're not an alkane. We've got a double bond, so it has to be an ene. We're going to need to give a position as well. So we're not ene because we've also got this ending, which is an aldehyde ending. So we're now enal. Now the aldehyde ending, this always comes at the end of a group. so we don't need to give that a position. But that defines where our carbon-carbon double bond is, so we're now at 1, 2, so we're but 2 E now. Could have been on the N carbon, which would mean but 3 E now. The skeletal formula for this one, there's our 4 carbons. We show a double bonded direction. We don't have the hydrogens. And there's our but 2 E now. This time we're going to look at a ketone. So I'll just draw the displayed formula for us first. We have a CH3, double bonded to CO. And then we've got the brackets at the end, which means we've got 2 methyl groups coming off. Here's my displayed formula. 1, 2, 3, 4. So we're now based on but again. We're only single covalent bonds, so we're an. We've got this group here, which is a carbon with 2 carbons either side. So we've now got own. In this particular example, we don't need to give a position because the carbon double bond oxygen can only go on the second one. If it went on the end, it would be an aldehyde. So actually, this is going to be butanone. And we've also got a methyl group. So we're now methyl butanone. The methyl group can only go on the second carbon as well, so we don't have to give those positions. Could say 2-methyl butanone. It wouldn't be marked down, but you don't have to give it in this instance. What would our skeletal formula look like then? Well, double bonded to oxygens there, and the methyl group down like that. Now we're going to have a look at the carboxylic acids. This time then, we've got carboxylic acid, because of the functional group at the end. We've got 1, 2, 3, 4 carbons in our longest chain. We're based on but, only single covalent bonds of butan. The ending, oic acid. And we then have a methyl group, which is a side chain. And if we count up, it's 1, 2, 3, from the third carbon. Remember, the carboxylic acid gives us a functional group and where we name it from, making this carbon number 1, 2, 3 methyl butanoic acid. Our skeletal formula, 1, 2, 3, 4. Double bond oxygen, OH, and the methyl group. This time then we're going to look at the amine group. Here we have the NH2 with the carbons side bonded off. And this time we've got 1, 2, 3 carbons in our longest chain. But we've got an amine group. So we're amine. And it's, because it's 3 carbons, it's going to be propyl. So we're propylamine. And then we've got to deal with our side group, which is methyl, and we're on the second carbon. So we're 2-methyl propylamine. Again, if we're going to do our skeletal formula, 1, 2, 3, and then NH2. So our final example here is the nitrile groups. And you can see here actually we've got a slight conflict in a decision to make, because we've got a nitrile group and an OH group. But here the nitrile group is going to be the primary functional group, and that's going to be where we number our carbons from. So we've got 1, 2, 3, 4. So again we're but, ane. Now, if our rule here is we never have a vowel next to another vowel or a consonant next to a consonant. So because it's butane nitrile, we keep the E in. So butane nitrile, not butan nitrile. And that is that chain, and we then have our side group here, which this time is an OH, and we need to use the prefix here rather than the suffix, so it's hydroxy, and the number, well, it's 1, 2, 3, so we're now 3 hydroxy butane nitrile. And finally, the skeletal formula for 3 hydroxy butane nitrile, slightly odd looking. We have the carbon there, and the OH. We've then been through worked examples of all of the homologous series that we might come across in RAS, except one example. We'll have a look here, which is a cyclo group. Here, the final example then, I forgot about the cyclo groups, is if we have a ring. This time we've got the skeletal formula. We have 1, 2, 3, 4, 5 carbons in our ring, so it's pent, only single bond, so it's ane. Because it's in a ring, we call it cyclo, pentane, and we number them as we go round. So we got 1, 2, dibromo cyclopentane. The thing about cyclo groups, they are functional group isomers of alkenes. And that does come to the end of all of our nomenclature that we might come across in the AS, and it's a case of then practicing and practicing, trying to draw and trying to name those species. So by now you should now be able to draw structural, displayed and skeletal formulas for given organic compounds, apply IUPAC rules for nomenclature to name organic compounds limited to chains and rings up to 6 carbons each, and apply IUPAC rules for nomenclature to draw the structure of an organic compound from the IUPAC name limited to chains and rings with up to 6 carbons atoms each.